Alright, in this lesson we'll talk about another rule for differentiation, and it's how we find the derivative of functions that are products of other functions. So here is sine from the previous lesson, but today we'll talk about x times sine. So there's a product of two different functions. We know the derivative of sine is cosine, but is the derivative going to be the derivative of x times the derivative of sine? If that's the right way to do it, then this would be true. But now let's see if that makes sense. If we draw the graph of sine, it's not the same as the graph of x times sine. So they shouldn't have the same slopes, and these shouldn't have the same derivative. So we know that this is wrong. We'll just put a cross there. That's not how we do the derivative of a product. We have a rule for this, and if we have g of x equals x sine x, it might be helpful to identify the two factors of the product, because we're going to use those, we're going to move those around, and then we have the derivative is, here's a good way to organize it, and we say it's the first factor times the derivative of the second factor plus second factor times the derivative of the first. You could make up some way of memorizing this. Some students like to say that this is 1d2 plus 2d1. So d stands for derivative, and 1 is going to be the first, d2 is the derivative of the second, 2 means the second, d1 means the derivative of the first. 1d2, 2d1. So that's one way to help you remember it. So let's try a few. F prime, and then this might help organize it. 1 d2 plus 2 d1. And if there's something to factor, go ahead and factor that. Here we have x's that we could factor out. Negative x sine x. We took out an x, so that'd be a 2 cosine x. Alright, pause the video and try that one. So we have 1 d2 is 12 x cubed 2 x to the 1 to the first power. 1 d2, then we do 2 d1. The derivative of sine is cosine. There's some factoring that could happen here. Let's see, we have an x squared. We could just factor out an x, so we'll just leave it like that. And here we have two factors. There's a product of two factors, so pause the video and try that one. and that'll be 1 d2 plus 2 d1. And we can just expand all that, multiply that. Here we can distribute this, and we'll have 2x squared and x minus 2x minus 1. So we get 3x squared. X plus x minus 2x is 0, and then we'll just have minus 1. Alright, pause the video and try that one. So G prime is 1d2 plus 2d1, 1 d2. The derivative of tangent is secant squared, and then we have 2 d1. The derivative is 2, and there's not much to rewrite there. We can just leave it like that. And we can, since we can find the derivative, now we can find the equation of the tangent line. So we have the slope and then point slope. Let's find the derivative of that. So that'll be the first times the derivative of the second plus the second times the derivative of the first. Evaluated at pi over 2, f prime of pi over 2 and sine of pi over 2 is 1, so that'll be a negative 1, negative pi over 2. Cosine of pi over 2 is 0, so we have the slope. Then the point slope, y minus y equals m, x minus x. And we need cosine. We want the y value at pi over 2. So put a pi over 2 there. Cosine of pi over 2 is 0 times pi over 2 is 0. And that means we're done. Negative pi over 2x plus pi squared over 4. Alright, pause the video and try that one. So we'll do 1d2, 1 d2 derivative, and then 2 d1, the derivative of that. Three x plus 3 plus 3x minus 1. We want the derivative at 1, so that's 3 times 1 plus 3, 3 times 1 minus 1, 3 plus 3 plus 3, 9 minus 1 is 8. Then point slope will be y minus y, m, x minus x. The y value at 1, if you put a 1 there you get a 2, put a 1 there you get a 2, so 2 times 2 is 4. And we're going to add 4, so that's 8x minus 4. And we can stop there.